Hey everybody, it's John Broadwell, creator of the Serial Wombat open source project and an embedded systems subject matter expert available for hire through my company, Broadwell Consulting. Today we're going to take a look at another one of the parts that comes in the Elegoo 37 sensor kit, one of the most popular sensor kits on Amazon. Today we're going to take a look at their joystick. So let's take a look at how we've got that hooked up to our Serial Wombat 18AB chip. This part has 5 pins. We're running power and ground to our 3.3 and ground line on the Serial Wombat chip. Then we've got the button running up to pin 0 and the Y and the X running to pin 1 and pin 2. So we'll configure a couple of those as analog, one as a debounced, and we will see how that works for us. I'm not 100% sure how this part works. We're going to experiment with it a little bit, and the easiest way to do that is through the WombatPanel application that's available for Windows under C#. So let's go to examples under Arduino, Serial Wombat Bridges, and pick the UART 115 to I²C. Essentially what that'll let us do is use the UART on the Arduino board, and then the Arduino will convert each packet that we send into I²C, then get the response over I²C and send it back over UART. So let's download that sketch now. Okay, now that that sketch is downloaded, we can use the WombatPanel application to talk to the Serial Wombat chip. So we're going to pick COM3 happens to be that Arduino board. I'm going to say OK. We'll give it a second to resync and inquire the Serial Wombat chip various stuff. We see it, okay, it found an 18AB version 2.10 as of January of 2024. That is the most recent, and it looks like everything's working good. So let's go ahead and open up. Let's start with the analogs. We'll open up an analog input on pin 1, and we will say configure using the default values and auto sample. 32768 would be right in the middle, and so it looks like the joystick's pretty well centered. Let's play with it and see what we get. Okay, and what we can see is as I move this guy on its y-axis, we're getting a nice run, 65, 535, and 0, so it'll saturate at both ends. One thing I notice is that there's a fair amount of dead zone on each side where I can move it, and it's still staying at saturation. It's probably a good thing because the size of this knob, if you were actually going to mount it inside of something, you'd want to make sure that you were hitting the edges of the potentiometer and not just where the knob hit your enclosure. So that feels pretty solid. Let's create another analog input on pin 2. And we'll test the x-axis. Okay, that one looks pretty well centered as well. We'll go back and forth this way. Maybe drag this over so that we can see both analogs at once. Okay, here's one axis. Here's the other axis. So that's working good. Okay, let's take a look at the button. We know we plugged that into Serial Wombat pin 0. And so we'll make that a debounced input because it's a button. Let's start with the pull-up disabled in case it has a resistor on the board. We'll say configure. I don't have a graph on that one, so we'll just monitor the public data and say auto sample. And it's sitting at 0. If I push it, does it go high? No. So it appears that this maybe does need a pull-up on that particular pin. So let's reconfigure this and say pull-up enabled. All right, that's good. It went up to 1. Let's push the button, and it drops to 0. So that's great. Let's go ahead and invert our logic there so that we get a 1 when we push the button. Okay, I like that. So let's see if we can do something that's a little bit more fun. Okay, what I've added here is a 2-servo camera controller, and it's being powered by a 5-volt separate supply. I always recommend having a separate supply for your inductive loads. Over here we have a board that I sell at serialwombat.com that's designed to make it easy to connect servos to your Serial Wombat board or a Raspberry Pi or Arduino or whatever. Essentially it has a row of servo connectors that breaks out the signal connector to a separate pin so you can connect it easily, and then provides a place to provide power separately for your servos. So these are pretty popular. Actually, they sell almost as well as the Serial Wombat boards. So if you play with servos a lot, I recommend picking one up. we're going to plug the two servos into pins 18 and 19. And let's come over here and say configure servo. And we will say just standard configure. And as I move that, we can see it moves it up and down. And so let's do pin number 18. That'll be the one that moves it left and right. We configure that as a servo. Say configure. And we can see that we can rotate the camera that way. So that's not real interesting right now because the fun parts aren't connected. And that's where the Serial Wombat chip's inner pin connections come into play through what's called the output scaling module. And so what we're going to do is we're going to tell the Serial Wombat chip for pin number 18, I want you to take the input from pin number 2, which is the analog input pin that's attached to the X on the joystick. So we'll say enable on that. And then we're going to tell it, I want you on pin 19 to take that input from pin number 1 and enable that. So now if we come over here, if we move this servo, or if we move this joystick, we can control those servos. And to be clear, what's going on here is the Serial Wombat chip is handling all of that signaling internally. None of that. It is coming back so that we can view it on the WombatPanel application. But at this point, if I close this guy all the way down, this will continue to function because the Serial Wombat chip has been configured. So let's now make it so that that is a semi-permanent state on the Serial Wombat chip. I'm going to go in here and I'm going to turn off all of my auto samples first because I don't want to capture those particular things. And I'm going to go in here and shut off my enables real quick so that we're ready to reconfigure this thing. And what else we got running here? We got a line there, shut that off. And did I close that monitor? Yeah. Okay, so we're going to go now to the main board and we're going to say port, we're going to go to command capture and say start. And we're going to go back again and configure those A to Ds. Analog input 1, configure. Analog input 2, configure. Debounce, configure. And what's happening is it is capturing each of those into flash memory. And every time that the chip resets, now it'll pull that out of flash memory. So everything I did previously, I'm doing now. Now I come over to the Serial Wombat main panel. I'm done configuring things, so I say stop and store. And we give it just a second to write to flash. Now let's close all these windows. Aside from the main Serial Wombat panel 1. And we're going to tell it to run the chip through a reset. And you can see we get a little glitch every time we do a reset. That's because the servo shuts off for a second. But now we come back here and we have that same control. So let's take that even a little bit further. We're going to leave the USB plugged in here because we need that. But let's pull the I2C lines. And then let's close this. And let's power cycle the Arduino, which will power cycle the Serial Wombat chip. We come back up and we can see we still have total control. So the Serial Wombat chip is essentially working independently of its host at this point, which is pretty cool. So if all you wanted to do was to have a set of servos that was controlled by the joystick, you actually don't even need an Arduino to do that anymore. You just configure up the chip so that the pins are tied together and you're good to go. Now, I don't want to keep that forever because I'm going to use this Serial Wombat chip for other things. So I'm going to go to port, open serial, COM3, okay. And I'm going to go ahead and reconnect my I2C lines. And by the way, you can see on my little ESP8266 board, I'm using these acrylic pins. If you're not marking your boards, your favorite pins, the I2C pins, the power pins with acrylic pens, you're really missing out on something. It makes my life really a lot easier. So let's go to port now, and we'll say close, and say open serial, and open it up again. Okay, so we got good connection on the serial wombat. So we're going to go to command capture now and say start, and then we're just going to say stop and store. Every time you do a start and a stop and store, it replaces what was in there previously. So we just replaced that with no commands, which is what we want going forward, because now we're going to control the thing using the Arduino. So let's go into Arduino, and we will go to File, Examples, Serial Wombat, 18AB, Serial Wombat Elegoo 37 Sensor Kit, Analog Joystick, and we'll pull up this. And basically this does pretty much the same thing, except it's going to actually use the host to control the servos. It's going to look at the button and print it out to serial if it's pushed. I didn't know what else to do with it. And then read the public data from one joystick and the other and write the public data. I'm not going to go through all the code. It's pretty self-explanatory. And so we'll say sketch upload. And by the way, if you're using C# or Python, those same examples will be available shortly. It uses all the same interfaces, so don't hesitate. Take a look at the C# video or the Python video, and you can also use all the things that we're seeing here. Oh, permission denied. It's because I've got this panel open. Let's try it again. Sketch, upload. Okay, now the pin's gone through a reset. Looks like my my battery shut off because I wasn't using the servo. Okay, now that that's loaded, we can move the servo. And in this case, it's actually the Arduino that's doing the commanding because we turned off the internal pin connection within the Serial Wombat chip. But we could also turn that back on programmatically. And in the future, I'll have another video that goes all through the scaled output and how to use that. There is documentation on it in the classes on the GitHub library, or if you look at the Serial Wombat 18AB user guide that's available at serialwombat.com. That's about it for the Serial Wombat chip connection to the Elegoo joystick that's included in the 37 sensor kit. This is actually one of my new favorite toys. I think I'm going to probably use this in future projects, maybe even come up with a pin mode for it that would allow you to accumulate data as you push the pin left or right. That seems like fun. So anyway, that's all I have for today. Like the video if you like it, and subscribe so that you can get Serial Wombat information. You can also follow me on Instagram for more frequent, smaller updates than the videos. If you're using the Serial Wombat chip for anything like this, leave a comment down below, or even better yet, send me some pictures or a little bit of video to help at serialwombat.com. I'd love to feature your project in a future video. So that's all I have for today. You guys have fun. Keep making stuff. The Serial Wombat firmware is available on GitHub and is constantly being updated. Subscribe below so that you can see the latest features and videos that come out as we fix bugs and add new features. The Serial Wombat open source project was created by Broadwell Consulting Incorporated. Broadwell Consulting Incorporated provides help developing medical devices with a focus on developing embedded firmware, which is compliant with IEC 62304, ISO 14971, and ISO 13485, as well as remediation assistance for products already in production. For more information, contact John at Broadwell Consulting. Support requests for Serial Wombat should be sent to help@serialwombat.com and will be answered on an as-available basis. Also, feel free to leave your question in the comments below.